All right, today what we're going to be talking about is the geometric mean. And the geometric mean of two numbers is the positive square root of their product. It's a proportion that can be written a couple different ways. You can write it like this way, where you have a over x equals x over b. And then when you solve it, the geometric mean of a and b is actually the square root of a times b. So here's the work up here, you can see. All right, so that's what the geometric mean is. So we're going to practice finding the geometric mean first. And so to find the geometric mean between each pair of numbers 4 and 9. So we'll make one of them a, we'll make the other one b, and we can set up our proportion that we have up here, where we have a over x equals x over b, which in this case is 9, and then again cross multiply. So you're going to get x squared equals 36, take the square root of both sides, and then that's going to give you 6 equals x. And remember, we're taking the positive square root, so that's why we don't do plus or minus. Another way to do it, so here's the proportion. The other way is just to go ahead and go right into this formula, where we say x is the square root of a times b. And we just plug that in, square root of 36, x equals 6. So either way works. All right, I want you to go ahead, I want you to try this one. And then here's another way of doing it where you already have a radical in there. So it's 3 root 3 is the geometric mean between 9 and what number? So we don't know, so we're just going to call that number b. So we're just going to take our equation that we used up here, and we're just going to substitute in what we already know. So if we know this is the geometric mean, that's going to equal a times b, or square root of a times b, and then we're just going to plug in the information that we know. So remember, if you're doing 3 squared, that's 9, and then square root of 3 times square root of 3 gives you positive 3, or gives you 3. And then again, we're going to do this and the root, cancel each other out. So you're just with 9b, and then divide both sides by 9, and you get b equals 3. So now, I want you to go ahead and I want you to try that one. And then now we're going to get into is more of the proportions with the shape. So this was just to find the geometric mean. Now we're going to talk about the geometric mean and how we can use it for geometry. So in this case, if the altitude is drawn from the vertex of the right angle of a right triangle to its hypotenuse, then the two triangles formed are similar. So if we were to draw here, we have this triangle. We also have this triangle within the large triangle. So all the triangles are similar to each other. And what I did is I actually took this and I broke it down here. So this is the large triangle. That's a horrible triangle. Try it again. A little better. So that's this guy here. And then this here is this triangle. And then this here is the smaller of the three. All right, so all I did was I just matched up the similarity. All of those are similar, and you can think about it because if you look here, this is the hypotenuse here. This is the hypotenuse of this triangle, and this is the hypotenuse. So all of this hypotenuse are the same, or are similar as far as corresponding sides. And then I just went through, I had your short leg, the short leg, and the short leg. Then I had the longer leg, longer leg, longer leg. So when you're seeing this, this is really what you're looking at here, 3 different triangles. But all the triangles are similar. All right, so one way that we can find this is the measure of the altitude drawn for the vertex to the right angle to its hypotenuse is the geometric mean between the measures of the 2 segments. So we're looking here, that's the altitude. And we're just going to find a geometric mean. So we're going to set up our proportion here. So to set up the proportion, you're going to take this part and you're going to do the proportion of b. So that's where we get a over b. So a over the B, and then we'll go ahead and we'll figure that one out. And then we can also have that equal to B over the C. So another way to think about it is you're basically doing a loop-de-loop. So you start with A over B and then B over C. So whichever way works for you, go ahead and do that. All right, so now we're going to talk about the altitude and the geometric mean, so we can use the proportions to find the altitude. All right, so you can either do your little loop-de-loo and make a proportion that way. So I know that this over this is going to equal this over that. So we just set up a proportion, and then we can cross multiply. So you get b squared equals b squared equals 45. Then take the square root of both sides. So you get 3 times root 5. So because this is 9 times 5, so that's where the 3 came from. All right, or if you were to enter it into your calculator, you get approximately 6.7. So I want you to go ahead, I want you to find EH. And again, you can do your little loop-de-loo here if you'd like, and set up your proportion to solve. Here you're going to find LM, so again, you're going to do your loop-de-loo. So it'd be 16 over this equals this over that. So go ahead, find that, and simplify. All right. Now this one is a little crazy. It looks pretty crazy here. With all the lines, but if the altitude's drawn from the vertex of the right triangle to its hypotenuse here, then the measure of the leg of the right triangle is the geometric mean between the measures of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So we can call this around the corner, and the lines look pretty crazy, but we can say B over A is equal to A over B plus C. So that's one way to think about it. Another way to think about it, I'll show you in a second. And then we can also have C over D, because that's the hypotenuse of the little triangle, is equal to D over this hypotenuse. So we're just setting up different proportions. If this is crazy, you can kind of look down here, and it might be a slightly different way for you to understand that you're taking your small triangle over your altitude, and then your altitude over the medium triangle. So this is find your geometric mean, if you need to do that. And then you can take your hypotenuse over a leg, and that leg is going to go over that. So it's a bunch of different ways to solve it. You pick which way works for you. But around the corner is just saying just that. You go B over A, because we're going around the corner. And then you're going to come back around and go A over C, because it's going to be A, all of that, over B plus C. So that's this part. And then we're going to go C, because we're going around the corner to D. And then we're going to go back around and do all of this. So again, if this works for you, you use this. So let's try this one. Okay, so first off, we need to find the geometric mean. So to find the geometric mean, we're going to do our little loop-de-doo here. And I set it up as 8 over Z equals Z over 3. Okay, cross multiply. Z squared equals 24. Then take the square root of both sides, and you can put that into your calculator. Z is approximately 4.9. Now that we know that this is 4.9, now we can start to figure out some of the others. All right. So now we can go ahead and we can figure out that if we were to go around the corner, so if I were to start here, and go around the corner to the hypotenuse. Then we got to go back around all of this. So you're going to get 8. Oops, did I write that right? I did not write that right. I thought that looked wrong. There you go. All right, so I changed this. So yeah, because when I was doing it, I was like, wait, 8 times x. That should be 8 over x. So there you go. And then now we're going to go x over 8 plus 3, which is 11. So 8 plus 3 is where we got 11 from. All right, and then cross multiply, you'll get x squared equals 88, and then take the square root of both sides, and that gives you approximately 9.4. All right, so now let's come down here, and we're going to do the same thing. We're going to go around the corner, so 3 over y equals, now we got to loop back around and do this whole thing. So we got 3 plus 8, which is 11, and then go ahead, cross multiply. And if you notice, if you do this correctly, your middle should be the same. So when you're looking at this, your denominator for one should be the numerator for the other. All right, so let's go ahead, let's try this one. So first what we're going to do, we need to find this guy. So we can do a little loop-de-doo. This y is 21. So we don't know what that is yet, but we can find that. So we're going to figure out I think this is supposed to say, oh, z. Okay, here we go. So in this, we need to first do our little loop-de-doo here. So we know if y is 21, we got that. And then now let's go ahead and I'm going to find this guy. So I can find that for x by doing 21. Wait, how did I get that? Ah, okay. Sorry, had a little brain fart there. Okay, yeah. So we're going to basically go around the corner. Whee! To get here. And then we're going to come back around and get all of this. All right. So that's how we set it up there, and we got that. So z is 25. So now that we know this is 25, this is 21. Now that we know this is 21, now we can do a loop-de-doo. So 21 over x equals x over 4. And then that's going to be 9.2. And then we already said y is that. So now we've got all three. So just remember when you're going around the corner, you got to come back around and do the whole bottom, which is that. All right, same thing here. When you're doing that, just make sure you figure out what this is. And you can go around the corner, which we should know this would be 4. So you can do your loop-de-loo here with 4. And then once you've got this as 4, then you can go ahead and go around the corner and then back around here. So again, whichever way works for you. I also have this if you just like pretty colors. So this is kind of the same as loop-de-loo, or same as around the corner. It's just a different way to think about it. So just remember different ways to find geometric mean. You could do proportion, or you just know geometric mean is the square root of a times b. Then once you get that, you can use it to find the altitude. And then once you got the altitude for the loop-de-loo, once you got the altitude, then you can start going around the corner and then back around. Around the corner and then back around for the total. All right, I want you to go ahead, I want you to try this, and then of course finish those if you didn't already, and that is your geometric mean.